Got another set of questions for the A-Level Chemistry Multiple Choice Practice playlist. So this is number 7 now for AS Chemistry. I've got separate playlists for inorganic and physical chemistry and organic chemistry for A-Level. Hope you like the video, and if you haven't already subscribed, why don't you consider subscribing to the channel. And as always, the link to the questions in the description of the video if you want to try them first. Okay, so make a start. So silicon, B, was the giant covalent structure, potassium's giant metallic, sodium chloride's giant ionic, and water's simple covalent. Number 2, definition test. So electronegativity is the ability of an atom to attract a pair of electrons in a covalent bond. So it was option A. Number 3, so A, ethanoic acid is an acid, obviously. B, methanol is neither an acid or an alkali. C, nitric acid, another acid. So NH3, if you put that in water, you've got NH4OH. And obviously you can see the OH minus ions now. And so that's the alkali. So D was the answer. Number 4, so I've just written up the electron configuration for sulfur. So you can see that there's a paired orbital 1s2, another one for 2s2, 3 paired orbitals for 2p6, 1 for 3s2, and then the 3p4 configuration. I've just done the electrons in boxes version, and you can see there's 1 paired orbital in there. So that's a total of 7, so the answer was C. Number 5, these are all simple covalent lattices in the solid state, so it's a bit of a test of your knowledge of their formula. So sulfur's S8, phosphorus P4, chlorine Cl2, and argon exists as individual atoms. So the lowest melting point would be the one with the least number of electrons, and that's obviously argon, so D was the answer. So number 6, we're looking for the big jump in ionization energy. So you can see it happens between second and third. So this element X is in group 2, so it's going to form the 2 plus ion. So it's chloride, remember chlorine forms a 1 minus ion, is going to be XCl2, so B. Number 7, first thing I'm going to do is work out the moles of O2 in those 2.4 grams. So obviously that's just mass over MR, and it comes out at 0.075 moles. Then we just apply the mole ratio, so you can see for every mole of oxygen formed, 2 moles of PbSO4 has been heated, so we just need to double that. So 0.15 moles of PbSO4 have been heated, so the mass, we're just going to multiply by its MR, which they very kindly gave us, 303.3, and that comes out at 45.5 grams, so the answer was C. Number 8, there's a couple of ways to do this, but the quickest way to do it is to just look at the factor change in the concentrations. So if we're going from 18 moles per decimeter cubed down to 0.45 moles per decimeter cubed for the hydrochloric acid concentration. So 0.45 is 40 times less concentrated than 18. So that means we're going to need to do exactly the same to the volume. So 250 divided by 40 comes out at 6.25. So that's the volume we're going to need. So the answer was B. Number 9, so we're interested in the ions. So 1 mole of MgCl2 contains 3 moles of ions, because you've got an Mg2 plus ion and 2 Cl minus ions. So that means 4 moles of magnesium chloride is going to be 12 moles of ions. So we need to multiply that by Avogadro's number. Comes out at 7.224 times 10 to the 24, so it's D. Number 10, so the halogens are all simple covalent substances. So we're breaking the intermolecular forces, which are London forces, because these are non-polar molecules. So as you go down the group, more electrons in the molecule, stronger London forces. So D is the answer. Number 11, so you can see we've got a table full of enthalpy changes of formation, and we're using it to calculate the enthalpy change for this reaction here. So therefore we need to use the formula delta H equals the sum of the enthalpy changes of formation of the products minus the sum of the enthalpy changes of formation of the reactant. I just remember it as FP minus R, products minus reactants. So I'll just put those numbers in, and you should get minus 555.8, so A is the answer. Number 12, so Le Chatelier's principle can't make any predictions about rate, so that means A is out and C is out. Catalysts don't affect the position of an equilibrium, so B is out, so that means D is the answer. Number 13, so at the heart of this is the Kc expression, so it's equal to the equilibrium concentration of the product raised to the power, I'm calling x. So x is just going to be the balance in numbers of the products, and divide that by the equilibrium concentration of the reactants raised to the power y. So that y just represents their balance in numbers. So we'll just work through them until we get the answer. So starting with A, so that means we've got 0.1 to the power 5 on the top because the balance in numbers add up to 5 of those products, divided by 0.1 to the power 3. So we can simplify that to 0.1 raised to the power 2, which is 0.01. So thank you, that's the answer. Number 14, so I've just drawn it out to show where all the sigma bonds are, and there's a total of 9, so D was the answer. Number 15, so those black dots there represent all the hydrogens, and when you count them up, there's 12, so C is the answer there. Number 16, so at the heart of this is the fact that volume is proportional to moles. So if we're getting 30 cm cubed of CO2 to 40 cm cubed H2O, that means the ratio is 3 CO2s to 4 H2Os. So that means the hydrocarbon must have been C3H8. So that's propane, so D. Number 17, so E isomers have the priority groups on opposite sides of the CC double bond. So you can see D's the answer, but I'll just quickly explain the priority groups just for revision. So the left-hand carbon, we're sort of comparing carbon with hydrogen. Carbon's got a higher atomic number, so it has priority. So that's your priority group on the left-hand carbon. On the right-hand carbon, it's a little bit trickier. So you've got carbon and carbon directly bonded. So we need to go further out. So look at what's bonded to those carbons. So in the CH3 group, we've got 3 hydrogens. So I just treat it as like a score. So it's 1, 1, 1 for those 3 atomic numbers there. The bottom carbon, it's bonded to 2 carbons and a hydrogen. So in terms of a score, atomic number wise, it's 661. So obviously that beats treble 1. So that's got priority there. Number 18, just a quick reminder of the trend. So the rate of hydrolysis for the haloalkanes increases as you go down group 7, and that's due to the decrease in bond enthalpy of the carbon-halogen bond. So D and C are straight out because it's got nothing to do with polarity. And then reading through statements A and B, B is the right answer. CBr bond enthalpy is less than the CCl bond enthalpy. Number 19, got no OH activity at all in this spectrum, so that means B, C and D are out. So that was easy, A was the answer, and your C double bond O is obviously that one there. And finally, number 20, so which alcohol can have fragment ions at these 3 M/Z values? So starting with 15, that's due to a CH3 plus fragment. And you'll notice that all of them can produce at least one of those fragment peaks. So if we move on to fragment peak 29, so that's due to C2H5 plus, and there's only 2 of these that can produce a peak there. So B can and C can. So that means that A and D are ruled out. So from B and C only, which one of those can produce a fragment peak at 43? So that'll be due to a C3H7 plus fragment, and hopefully you can see that it is C. So that's the answer.